Hello there and welcome back to our second episode. In this episode, we shall be building Mantis from source. So if you've not watched the first episode, look at it. And in our first episode, I covered mostly more about what Mantis is all about and how to get started with the pre-built binary. For this episode specifically, we'll be delving into how to build Mantis itself from source, as well as try and look at the source code that we have for Mantis and basically how to navigate around it. So a good starting point for this case is our GitHub repo, where we have the full source code for the project. So if you want to get started, of course we need to clone this repo. So I will follow these commands as they are here, basically to show you the same flow. Let me get a folder to work with. So I'll create this folder here called tests, and then from here, let's open the terminal from this point, and then just to make it legible, I'll paste that there. So we are cloning the Mantis repo, and we are doing it recursively. Why? We have some recursive submodules that we need to fetch. This will take some few minutes depending on the connectivity. So if you run that, first we need to fetch the Mantis code base. Once that's completed, we need to go through all the submodules, and we'll be covering that in a short while. So let this finish first. Good. So after a couple of minutes, we have all our code base downloaded, including all the submodules as well. So from a particular directory, we have the folder created called Mantis. So we can do cd to Mantis, and here you should see a very big structure of the full code base we are working with. So from the top part, all the third-party files are actually located here, and this is where we are storing all our submodules under this third-party directory. And this contains the CMRC. CMRC is the CMake resource compiler that allows us to compile all the dependency files into C++ files. And then we have HTTP lib for HTTP server. We have the JSON for handling JSON serialization and deserialization. And then we also have lightweight L8W8JWT, so it's called lightweight JWT, a C library for handling JWT. The other dependency we have is SOSI. SOSI is a database abstraction library that allows you to connect to any SQL based database, and then you have speedlog for logging. So apart from that, we also have argpass for argument passing on the command line. You have cpass for passing and evaluating expressions that you're using for authentication and authorization, and then you have libbcrypt for, of course, cryptography. So all these have been a bit modified. That's why they are actually in a different directory. So they are no longer actually coming in as submodules. They are part of the code base itself because they've been modified a bit. And then in part of the include, so we're including Mantis, and under it you have an app. App will have the main application, and then under the core. So the core and the utils will all be built into a single library. So then the app itself will be linked to it and built into Mantis app. So the Mantis app comes from this first part, and then the library itself is from all these other parts. So let's open this in Visual Studio Code just to show you how it looks like. So similar structure what I was explaining. So we're working with CMake. So for a particular case, in terms of the kits, I need to work with, okay, let it finish first. So we're working with CMake, and for this particular case, everything has been tested against GCC compilers, not MSVC compilers on Windows. Initially, the build on MSVC was breaking. I'm not sure if that's still the case. I think for now it should be building correctly, but I need to check on that. But for now, for 100% compatibility, work with GCC compiler. So on Windows, you can work with the MinGW. On Linux, of course, you can just install GCC. And then the next requirement, of course, is you need at least C++20. So look for a GCC 20 compatible build. And this, of course, is because we have some dependencies like using the std format, which was included in C++20, and I believe some early compilers for C++20 didn't have that functionality in yet. So you might find an error. So test it exhaustively first. You can try and compile. If it throws an error, get a new compiler. Now, for us to build this code base, so I will be using CLion IDE. Basically, that's where I'm more comfortable working with. So let me see if I can do CLion here. Good. So this is opening separately. So in terms of building it, so as I said, we will be working with MinGW. So our default configuration toolchain should be set to MinGW, and then we'll be working, of course, with MinGW makefile. So everything here should remain the same. Then once you set that in, that should be good to go. Let me see if I can zoom in. No, I can't. Okay. So this looks to be so small. Let me try and zoom in a bit. Good, I think that's better. That's more visible. So this is a CMake file we'll be working with, and then I think I'm waiting for the CMake to complete. Good. So I think CMake has completed, and one of the first requirements if you run CMake is it will kind of fetch the admin dashboard itself, because it's not part of this code base. It's part of a different repository, which is linked to this particular repository. It will kind of fetch a zipped version of it, and then uncompress to the build directory. Then it will all be compiled down into C++. Everything is within the same binary. So a walkthrough of the codebase itself. So if you come to include, so you have the Mantis, and then under app you have the app.h, and this basically has everything to do with starting the application itself. And then the config is basically a template allowing you to inject particular versions at build time. So when CMake, when you're building when you're running CMake, it will kind of create a config.h file that will be included inside the binary. And then the core part handles everything which is core, starting with the settings part for the application, routing, and then you have logging, JWT handling, you have HTTP server itself handling it, and then file unit, and this will handle everything to do with creating directories, writing the files out. And then you have the expression evaluator, and this will handle evaluating expressions. This will be used, as I said earlier, in authentication and authorization. And then everything to do with the database itself, connecting and disconnecting, creating different pooling, logging, and much more. So under CRUD, we have basically a single table here. Basically is an abstract interface class. And then under models, this is where we are defining the structure of different things you're working with, to do with validation, table types, field types, and much more. All of them are actually inside the models itself, but this is implemented inside different classes depending on the categorization. And then under tables as well, this defines how the tables need to contain and how it should be implemented in terms of fetching the data, writing the data, and much more. So if you want to understand how data is flowing, how the flow is going in terms of how the authorization happens, you need to look at now the tables flow. This has two variants. We have the tables for normal tables, and then you have the system tables. And system tables basically has to do with the creation and deletion of different tables. So it has a different flow compared to the normal records we can work with. And that's all about it. So all the implementation are actually inside this source file, and this is what creates the Mantis app itself. So it's basically, it includes the library, includes the Mantis app itself, initializes it, and then basically runs it. So this running will start the HTTP server and allow everything to run from there. But if anything happens to it, it will return the error code from this particular point. So if you count the app, I think we have looked at it. So this will maintain a single static instance of the class called the S instance here, and this prevents you from having multiple Mantis instances at the particular time. For now, this is the design pattern, but might change in the near future depending on how we see things going. So this allows you to create an instance, setting up, and because you have a static instance, all other dependencies on this particular file will basically call the static instance, get a particular instance, and then invoke the particular method they want to get data from. For the core part, of course, we have looked at it, and then you have the utils. So to build this, I will switch to, let me switch to release with debug info, because the debug build takes a lot of time. So let me just switch to release with debug info. I will do here, okay. So if you run this on Linux and you have installed Asan, that is the address sanitizer, so it should automatically build with it. If you've not, then it will kind of skip. And note that for testing purposes, the tests are currently a bit broken because of some memory issues, so it's kind of causing the test to break, but that's being worked on. So with this, we can basically run this now. So this will take around 5 minutes to 10 minutes depending on how good your PC is. But after the first build, everything should be a bit faster. So once your build completes, on automatically using an ID, it will try to run the built binary. So this is what we are seeing in our previous episode when we are talking about how to run the binary itself. So for it to run a server from this particular one, I need to change. I need to add the configuration here and provide documents. So for our case, I can add the dev build. Then I can also do serve from here. So if I run this again, so now at this particular case, then everything runs as expected. So because everything is running from a particular build directory, so we are running a release with the back information. So if you open this, you come to bin, you should have the binary file here, and inside the data you should have the files being created. These are the files. This is the SQLite files that stores the data for this particular case. So if we need to log into this, then we need first to provide the default username that you want to work with, the default admin user. So you need to run this binary here on this particular directory, providing the admin username and password, and that allows us to log in to the admin dashboard. So for our case, I want to log into PostgreSQL. So I will come to edit here and I will do database to PSQL. Connection, I will do a string. Here I'll do db name to Mantis. Host, I will do port, and then user. So if you're not aware about what I'm doing here, I'm basically providing a connection string for PostgreSQL, which is running inside a Docker container in my PC. So one of the things to note here is that this will fail to connect, and I will explain shortly why. So if I do that and I do apply and I do OK, and then let me run this one. So it will tell you that this has not been implemented. Why? For PostgreSQL connection is only implemented for Linux build, not for Windows. We are running this in Windows, but for our case, we can add let me get this, delete them. So the build type should be released with debug information, and then I want to use WSL here. So this allows me to build for Linux from Windows itself, Unix Makefile. So that should be fine. I'll do OK. So the CMake will run. This will just take a couple of seconds. So unfortunately, we'll have to rebuild the whole source code again from scratch. So this has been done. So if I come back here, this is not yet done. Yeah. Oh yeah, I'm seeing the wrong tab here. Seeing here. So now you're enabling PostgreSQL backend. So we'll let this run. We'll be back once it's completed. Good. So once the configuration files have been generated, we can now switch to WSL build and just basically run our application again. So this will rebuild everything from source again, but once completed, it should automatically now run and connect to PostgreSQL. So let's let this run and then be back shortly. So our build failed, so we need to check on why that's the case. So I'm not sure why it failed, so let me just rerun. That way I can get a shorter log. Okay, so this build was a bit long. Why? Because we were kinda linking it. We have enabled the address sanitizer, so that kind of makes the compile time a bit longer. But that's basically for as long as you are building in debug mode or release with debug mode. For release mode, we don't have, it's actually not included. And then two, initially we're getting an error when we're building. I couldn't figure out why. Rebuilding it again just kind of fixed the whole issue. But now everything is running correctly. So similar to what you are seeing in our last video when you're talking about connecting to PostgreSQL. So check that video if you have not. We are getting the same APIs created, so everything is working well. So if we switch to Mantis dashboard, this is it. So if you refresh our tables, you should get the same data, and you should see all our actions being logged down here. So everything still works okay, just similar to what we had seen in our previous video about how to work with the dashboard itself. Creating a new maybe table. You have a new test table, you can create a new record. Good. So everything still works okay, so no issues per se. And this was basically to show you how to build Mantis from source. And if you need to basically integrate into your current code base, what you need to do is all this is actually building into a static lib Mantis, and so you can always link to it directly. And then how you are able to start it, you come back to so if you come up to mantisapp.cpp, it basically shows you, so you need to include app.h, and then in your own code base you need to initialize Mantis. You need to create a Mantis instance, initialize it, and then run the server itself. So all this needs to be done within your own code base, but everything is actually provided within this one for these purposes to work. So as simple as that, nothing more complex. So that's all about how to build it. So as noted, some things to note about. On Linux, for you to build and link against PostgreSQL, then you will need to install the PostgreSQL developer libraries. So you need to do I think it's psql-dev to get the header files, as well as the libraries to link to. That should allow you to build a link against PostgreSQL. For Windows, the support is coming soon. Some work is still in progress, but once that's completed, you should be able to have parity in terms of feature between the two platforms. So I hope you found this interesting. If you experience any issues while trying to do the same, feel free to reach out through GitHub, create an issue, and we'll get some response out of that. With that, thank you for sticking around. I will see you in the next video. Bye.
Bye.